Hi there, Charlie Blaze here for Devlog 4 for my Artificial Intelligence for Creative Technologies project of image categorization. Let's jump in and see what my goals for this week were. And it was to try a different format for my model, test some different layers and rules to increase accuracy and get some better results. So last week I had a model made and system, and it was learning in quotation marks, but it really wasn't giving any sort of results that were substantial. So I rewrote my my whole system, along with changing the loading method and changing the model based on some suggestions I found online. Things were recommended, stuff such as having less like dense and conv2D layers, making a different function or using a different function for making my data sets. Just different ones, different versions were sort of suggested, and with these new and improved changes, there's actually something to show. It actually works. So you can see this chart on the top. This graph was what I showed last week with this weird up and down flatlining of validation accuracy, and my training accuracy not getting much higher than 16%. But as we can see on the bottom one there, it's skyrocketed. Well, higher than 16, but yeah, it's definitely better at reaching just under 35 after 25 iterations of the network. But accuracy isn't everything, and this is something I realised after searching up a lot of stuff, and loss is more important, because as much as accuracy is an obvious way of showing how good a system is, it's not really showing what's happening in the system. And I'm able to look now, and I'm focusing a lot more on looking on these loss values and this validation loss, and seeing what's happening in the system. And I've noticed the number one problem that I've got in my system is overfitting. It's a very common problem for neural networks, but my network absolutely loves this overfitting, where the validation loss, it follows the loss to an extent, and then it just goes off. And this is based on basically the system being smart enough to just sort of remember the images, as opposed to learn what the identifiers are for the categorization. So instead of identifying, or it has these features for this image, it just remembers, oh, I saw that image before, and submits that. So for categorizing the training data, it's great, but anything new that it hasn't seen, it's got no idea. So this was where I came to having to test different layers and rules to try and increase this accuracy, but actually it's mainly focusing on reducing the overfitting. Before I thought it was accuracy that I want to be doing, but now it's all that overfitting, and the accuracy will come later. So yeah, I had multiple different changes to the test, such as adding data augmentation. So now the images, the training images, are now flipped horizontally or vertically randomly, along with being rotated slightly, and also having some sort of zoom. So really giving a lot of different types of data shown to the network in the learning phase, so that they can learn all the different ways how to identify these Pokemon that I'm using. I also added multiple dropout layers, so it's kind of adding sort of noise to the images, removing half of the nodes or the parts during the layer in between layers, and then yeah, just basically tweaking input and output amounts for the different layers to see the results, see what's happening. So yeah, what was happening was the complexity of the network was smart enough to sort of recognize images it's already seen, but it wasn't smart enough to categorize new images. So yeah, this was one of the biggest struggles I've had for the last week after getting the neural network running now, and now we're getting to getting better results. And here we can see the current system, whereabouts it is. So actually, this is only a very recent discovery, but now I've changed my system, so now there's a lot of underfitting, which is marginally better than overfitting, in that it means that because it's underfitting, we have this validation loss below the loss, and the validation accuracy higher than our training accuracy. it's usually because either the system is too simple and it can't learn at all now, or it hasn't been ran long enough. And you can see down here, after 1,000 iterations or EPOs, it's getting to around 35 to 40% accuracy, which is pretty good. I did set it off to do 10,000 EPOs that I was hoping would be done for this video log, but actually my laptop decided it wanted to reset, so I don't have that data. But next week we'll be able to see if it's too simple and it won't learn and I have to go back to the drawing board, or if it just needed to be ran longer to try and get that, to train that model to learn all of these sort of identifiers. So yeah, that's the end of my devlog for this week. For next week, I want to find a better balance of complexity if the test that I'm doing doesn't come back positive, and basically have a strong image categorization AI for the final week. Thanks very much for watching.